Hello, dear students. In this video, we are going to see about what is left recursion and how to eliminate the left recursion. So already in the compiler, we know that the first phase of the compiler is lexical analysis. In the lexical analysis, we'll get the high-level language and convert it into sequence of tokens. So tokenization will be happen in the first phase of the compiler. This sequence of token is given as a input to the second phase of the compiler, that is syntax analysis. Syntax analysis is also called as parsing. So the basic of all this thing is already discussed in the previous video. Hope you have checked it. So what is parsing or what is syntax analysis means? So it will check whether the given input string can be derived from the given context-free grammar. So input string is also there, that is sequence of tokens. And we will also have the rule of the programming language in the form of context-free grammar. So we have to check whether the given input string can be derived from the context-free grammar or not. If I want to say it simply, I have to check whether there is no syntax mistakes in the given input string. So how will I check? Using this context-free grammar, I will check it. So this process only we call it as parsing. So this parsing we can do it in two ways. One is top-down parsing, other one is bottom-up parsing. So in the top-down parsing, we have the method of top-down parsing is called as LL parsing. So already we have discussed all this top-down parsing. So LL means left to right scan, and derivation will be done through leftmost derivation. So if I want to do the parsing with the LL parsing method, that is top-down approach. Top-down parsing is only LL parsing. So if I want to do the parsing in this method, the given context-free grammar should be free from ambiguity. So how to check whether the given grammar have ambiguity, how to eliminate all this thing we have already discussed in the previous video. So please go through it. And the given context-free grammar should not have left recursion. Left recursion should not be there. And the other one is left factoring should also be not there in the context-free grammar. Then only I can do the parsing. Parsing means we have to check whether the sequence of token doesn't have any syntax mistake and which can be derived from the given context-free grammar. So if you want to do that parsing, the given context-free grammar should be free from ambiguity, free from left recursion, free from left factoring. So in this video, we are going to check or we are going to see whether the given context-free grammar have left recursion or not. If it is having the left recursion, how to eliminate it. So how will you check whether the given grammar is having a left recursion or not? So that is what explained in this slide. So if I, let us take an example. If I have a production from a context-free grammar in this form, A tends to A alpha, it is one of the production from the context-free grammar. So if I have such kind of production, if you see here, the left side non-terminal and the first symbol in the right side is same. So if both are same, then this will cause left recursion. Why? Because, for example, if I construct a parse tree from this, A can be derived to A alpha, right? That is what given here. And this A again can be derived at A alpha. So this will keep on repeating. It is leftwise, it is recursively repeated. This A can be again written as A alpha. This A can again written as A alpha. So this leftwise, it is recursively coming again and again. So this is what a left recursion. So let me take give me another example. For example, if I say E tends to E plus E. If you this is a production. If I write a parse tree for it, how does it come? E can be derived to E plus E. Again, this E can be again derived to E plus E. And this E can be again derived to E plus E. So again, this E can be again derived to E plus E. So this will keep on going, right? So this process, this way of deriving again and again the left one, left symbol. So this we call it as left recursion. So we are going to, so I hope you understood what is left recursion is. So in this slide, if you see here, it is given as A tends to A alpha. If this is in the format, it is having left recursion. There is a plus, right? What is the meaning of plus? Plus says the input string can be derived in one or more steps. So that is what the meaning of plus. So if you have this kind of left recursion in your context-free grammar, then you cannot pass that input string with the help of top-down parsing through that context-free grammar. So we have to eliminate it. So if I want to eliminate it, how will I do is, I have, for example, the rule for eliminating this left recursion is A tends to A alpha beta, if this is the case. So here there is a left recursion. So how will you eliminate the left recursion out of this production is, write A tends to take the other production which is not starting with A. So here this beta, introduce a new non-terminal variable, and then that A dash tends to take the other symbols followed by this A. Here it is alpha, and then write A dash and introduce one new production epsilon. Epsilon is empty string. So now you can see from here, this production which have left recursion is now converted to this. So hereafter, don't use this production. Instead, you use these two productions in the grammar. So that is what explained here. If you have a rule like this will be converted into. So same thing which I have explained you is given here. So let us take an example and we will discuss. So let us take this example. Let me write it for you. So what is given here is, it is said as S tends to S plus T, and T tends to T into F, and F tends to ID or parenthesis S. So this is what the context-free grammar given, okay, to parse. So if you now look at this context-free grammar, you can clearly say this production have left recursion. This also have left recursion, because this both are same, this both are same. Now we have to remove it according to the rule. So what you have to do, let us go one by one. So first, let us take the first production, S tends to S plus T. So this is what the first production, let us take it. So according to the rule, what is the rule? A tends to A alpha beta means A tends to beta A dash, and this A dash will be alpha A dash epsilon, right? This is the rule. So this can be converted to S tends to the other production which is not starting with S is T, and introduce a new non-terminal S dash. Now, what is S dash? S dash is take the remaining symbols other than S, that is plus and T, and then S dash, and then introduce a new symbol epsilon. This is according to this rule, right? So now this production is not used hereafter. Instead of this, we have to use these two productions. Similarly, now let us take the second production. What is that? T tends to T into F. So here also we can understand there is a left recursion. Here is a left recursion. So how to change it? You can pause this video for a minute and you can try and then check it. So T tends to F, the other production is not starting with T, and then introduce a new variable or a non-terminal. Then what is T dash? T dash is the other variable symbols after T, that is star and F, then T dash, introduce a new production with epsilon. So we have finished. So this is also now converted, and the rest is F. This production doesn't have any left recursion. So what are our new productions? The new productions are, let me say, this is not used hereafter, right? And similarly, this is also not going to be used. So these are our new productions. Along with that, I have to also add this one. So that, what is that? F tends to ID, yes. So this is our new context-free grammar. So when you do LEL parsing, that is top-down parsing, instead of the given context-free grammar, we have to proceed with this 5 productions. This is our new context-free grammar. right? So this is how we have to eliminate the left recursion. There is a problem in left recursion. What is the problem? For example, in some of the productions, if you look at it, you cannot directly see the left recursion. If you see in this production, if you see S tends to A dash B, no? Here, if you see directly, you don't have any left recursion. And if you see in this A tends to SC, there is no direct left recursion, but still there is an indirect left recursion is there. Let me explain you. Let me take the same example given in the slide and I'll explain you how it is. So if there is an indirect left recursion, what you have to do is take it. Let me write it. It is given as S tends to A, B, and then A tends to S, C, D. This is what given in the slide here, right? So this is what I have written there. So now if you directly say there is no left recursion, but there is a left recursion. What is the first thing you have to do is if you look at this context-free grammar, there are two non-terminals, right? S and A. So you have to order it in any way. So in the first time, in case one, first I'm going to take A and then I'm going to take S. Or you can also take S first and then A. So first take S first, then take A. So S means S tends to capital A, small a and B. So here when you see there is no left recursion, leave it. And then go and take the next production, this one. So that's what we have. Second is A. So A tends to S, C, D. This is what the production. But now we know what is S. S can be derived because it is already known. So what I'm going to do is I'm going to rewrite it as yes, A tends to. Instead of this yes, I'm going to write this. Right? So how will I write? I'll write it as instead of this yes. So yes can be two options. What are two options? Yes can be A. Also yes can be B. Right? These things you have to write. So I'll write it as first time. Let me use the first production A and then C. This yes is also can be B, right? So I can say BC and then D. Got it? Now if you see there is a left recursion. How will I change it? A tends to take the remaining production. So BC A dash also D A dash. And then A dash tends to AC A dash epsilon. Got it? So let me give you one more example so that it will be clear for you. Okay. Let me remove it and I'll take one more example and I'll explain so that it will be little more clear for you. So what is the production I'm going to take this time is another production similar to that A, B, and then A tends to A, C, and S, D, F. So what is the first thing we have to do? First, we have to order it. So the case one, we are going to order it as, first I'm going to do the S and then I'm going to do the A. So write S. S productions are A, and B. If you directly see, there is no left recursion. Let it be. And let us go for A. So A tends to AC, SD, F. Now you know what is yes. You can see there is actually a left recursion here. But now we can do the substitution for yes because yes means yes can be A or yes can be B. So this two we are going to apply. So A becomes AC. Instead of this yes, I'm going to write A, then D, and also this B, D, and F. Right? So what we did here is, this one I have written as it is. This yes is now replaced by A, then this D, and this yes can also be written as B, right? This one. So B and then this D and then this here. Now you can see this have what? Left recursion. So now I have to remove this left recursion. See, this is similar to this and this. So now I have to solve it. How will I rewrite it? A tends to take the rest, right? So it is not starting with A. So B, D, A dash and F, A dash. Now I have to say what is A dash is. So take the other one. C, A dash and here the remaining A dash and introduce an epsilon, right? So now this is, instead of this grammar, we have to use this grammar. And so now what are the new grammars? So now the new grammars are this yes and then this two A productions. So now we have to use, instead of this, the older one, this and this two. So totally three productions, right? Okay, similarly, now in the case one, we have ordered it yes and A. The next time we will change it. We can order as A and then yes. So let me write it again. So what is actually the same question I'm going to write? So same question is S tends to B and A tends to AC. Same question which I have already wrote. Okay. So now earlier we have ordered first yes, then A. Now I am going to order it as A, then yes. Okay. So now let us see in this case as well. So if I write the production A tends to AC, S, D and F. Okay. So if you take in this case, if you directly see, there is a left recursion, right? So I have to change it. So how will I change it? A tends to take the remaining. S, D, A dash, and F, A dash. And according to the normal elimination, then what is A dash? A dash is C, A dash, and introduce an epsilon. So in this case, if you see what is over, this is over. S is over. So we done with A. We done with A. A is over. Now what I'm going to do, I'm going to solve this yes. So now let us write yes production. A, B. Okay, if you look at this, now we know what is A is, right? What is A? Here it is defined. Here it is. So now we have to substitute for all those A's. So this A can be written as S, D, A dash, and this A. This A, okay? And we have one more alternative for A. What is that? A can be written as F, A dash. It is given here. A can be also written as F, A dash, and the remaining this A. So this remaining A and this B. So now you look at it. This is A, right? Okay, now look at it. There is a left recursion. So what do you have to do? We have to remove the left recursion. So how will you remove? S tends to take the remaining, which is not starting with yes. So F, A dash, A, S dash, and also B, S dash. Now what is S dash? Take the remaining things other than S. That is D, A dash, A, and introduce what? Introduce the epsilon. Okay. So I hope you got it. So S dash is okay. D, A dash A, and epsilon. This is how we have to do eliminate the left recursion even if there is no direct left recursion. So hope you got it. Okay. So now let us discuss about the algorithm for this left recursion. What is the algorithm? What we did here, first we arranged the non-terminals. So here we arranged non-terminals. How we arranged? First we took A and then yes. Here in this case, first we took yes, then A. So that is what? Arrange non-terminal into some order, any order. And then we have two for loops. The outer for loops go until there are number of non-terminals. In this case, we have two non-terminals. So 2 times it will go. 1 to n is 2 times. If you have 3 non-terminals like S, A, and capital B, then this for loop will be going for 3 times. And then if there is no, if there is a direct recursion, then take the first production. If there is direct left recursion, eliminate the immediate left recursion in the production. If there is no direct left recursion, then come inside the inner for loop. What will you do? There is no, what we did here, we replaced all this A with the value of it, right? So what we did here first, we replaced all the yes with the production of it. So for this yes, the two production, so we replaced it. Here we are replacing, right? So first you have to replace it, and then we have to do the left recursion. So replace each production. For example, if you have a production AI tends to AJ gamma, then this AJ has a substitutions. What is AJ? AJ is alpha 1 up to alpha k. So we are replacing this AJ with alpha 1, then this gamma, then alpha 2, and up to alpha k gamma. So that is what the algorithm for indirect left recursion. Okay. So this example only we discussed here, and we got this result. Okay. This one. This one is here. We have already discussed. So which is given here. So this one we have discussed, and we got this output. Already we have discussed. And also when we rearrange it in different order, also we got it, right? So that is also given here. So you can see this. So hope you have understood this. Let me give one more example so that you will be understanding it more clearly. So let me take a new example for you to understand it better. So this left recursion, let me take a new production. Capital S, all S are capital, okay? So this capital X, then S, terminal, then X, S, and small a. And there is X means S can be derived as this. So in this context-free grammar, this is another example. Okay, it's another example. So in this example, I have this production. So S can be derived as in this way, or in this way, or in this way, or in this way. So similarly, capital X can be derived as in this way or in this way. So according to this elimination of the left recursion, what you have to do, you have to order it. So now if you look at this, you can see there is a direct left recursion. So if there is a direct left recursion, what will you do? We will eliminate it, right? So I'm going to write this. S tends to S, X, S, S, B. No. So this is the original production. How will we rewrite? S tends to take the remaining production, which is not starting with the S. So X, S, S dash, and then this A, S dash. Now I have to say what is S dash. So other than this, you have to take it. So it will be X, S dash, and S, B. This one, this two, okay? S dash. And we have to introduce a new epsilon. Got it? And now, so this is the new production. Along with that, we have capital X, S, A, X, B. So this one. This one also I have written here. So now this is our new production. Now, what we have to do is, this X, we have to rewrite it. So, rewrite this X production. How will I rewrite? X tends to substitute all the S. So this S we have to substitute. How will you substitute this S now? So this S have two options now. One is X, S, S dash, and this A, and this A. Also, the remaining X, B. So now I got this production, right? So now what will I do is, so if you see here, X, this S is now replaced with this. Now S has two productions, right? So what I'm going to do before this, I have to write the other one as well. So one is this option, other one is this option. So I'll write A, S dash, and then this A. Then the remaining XP. So this S is replaced one by this option, another one this by this option, and then XB is written. Now, if you see here, you have a left recursion. Where are the places you have left recursion? Here I have and here I have. So how will I rewrite? X tends to take the other production which is not starting with X. So A, S dash A and then X dash. Now I have to say what is X dash? The remaining things here. So S, S dash A and X dash. Also this one. B, X dash and epsilon. Right? So the remaining thing other than X I have to write. So this is what the new production for X. So now hereafter we are not going to use this. After replacing, we got indirect left recursion also, and we have eliminated it. So hope you got it. So if you want to understand it little further, let me take one more example so that you will be very much clear. So let me take the next example. Example 2. So here let me take a grammar. A tends to B, X, Y, X, and B tends to C, D, and C tends to A, and this is small c, and then D tends to D. So this is my grammar, context-free grammar. So we have to do it. So if you look at this both, there is no direct left recursion, right? So if you look at here, there is no left recursion. If you look at here, there is no left recursion. When you come here, what happened? You can replace, we know what is A. So I can replace A. A means what? This is one option. This is another option. So I'm going to rewrite this C. Why I'm doing, when I directly look at here, there is no replacement. Here, see, what is C, what is D, we don't know already. We don't know already what is C. There is no replacement. So these two are as such. But when you come here, we know what is A, right? So I'm going to rewrite this production. So how will I write? C tends to A, and this is small c, okay? So this we are going to rewrite. So I have to substitute this A. How will I write? For A, I have two options. One is B, X, Y, okay, and then other one is X, okay, and this C as such, right? So this A is now replaced by this, and this X, and then this C is written as such. So that's okay. There is no problem. And now we are going to write the D as such. Right? So now it is okay. Now, if I am going to write all the new productions we got. So, what are the productions we got? A tends to B, X, Y, X, and now B tends to C, D, and C tends to C. So C tends to, what is the C we got here? It is here. C tends to B, so it is here, no? C tends to this one we are going to write. B, X, Y, X, small c, and D tends to D. So what I have written, what was there here is I have written. So this is written as such. This is also written as such. And now C is already converted in this way. So that I have written here and I have written here. Okay. So what I have written here, I have written here. So now look at here. There is no problem here. No substitution also can be done. Here is also no substitution can be done. Now look at here. B. We know what is B here, right? So that substitution I can do. So what will I do? This C is now converted to C tends to, instead of this B, what I'm going to do? B means what? C. B means what? CD. So I'll write CD, and then the remaining things present here. What is the remaining thing? XY. So X, Y, and the remaining X and C. So when you look at here, it seems to be no left recursion. But when you do the substitution, you can now see there is a left recursion. See this one and this one is same, right? Now this we have to remove the left recursion. So what will you do? C tends to the remaining production which doesn't start with C. So that is X C dash and this C, small c, C dash. Then C dash tends to other symbols other than C. What are they? D, X, Y, C dash, epsilon. Got it? So now this production is now rewritten by this way. So that's it. Okay. So what are the now new productions? A, this production is written as such. A tends to B, X, Y, X. No problem here. And now B tends to CD, which is here, is written as such. No problem, no left recursion, no substitution can be done because in this case, we don't know what is C, what is D. And now this C is now replaced with C tends to X, C dash, C, C dash. This one we are writing, okay? And this C dash tends to D, X, Y, C dash, and epsilon. And so here also, if you see now, there is no substitution. We don't know what is C already. C dash is not no. So no problem. Now no left recursion, no substitution also can be done. And finally, the last one. D tends to D. Now this is our new context-free grammar, which is free from immediate left recursion, also indirect left recursion after we do the substitution. So by all this example, you might have well understood how to remove the immediate left recursion, also how to remove the indirect left recursion. Hope you have got it. If you have any doubt, go again back to the video and look at it. So definitely you will understand. Thank you, Ma. God bless you.